All right, so for 1/6, we are adding in that last step where it says like move the variables to one side and then the constants to the other. So we're going to go over the difference between what we've done right now, combine like terms. So combine like terms is what we've done so far. So I'm going to give you an example of that and then compare it to what we're doing now. So if we have like, okay, so write that down. So this is what we've already done. So draw your line down. All right, so what you're doing for combine like terms, that phrase we use whenever your like terms are on the same side of the equal sign, okay? So what you're doing when you're going into a problem, you're just looking at the left side. Do I have like terms that I can combine on this side?
Yes.
Yes, what?
8x.
Yep, 8x minus 4x, what's 8x minus 4x?
4.
Yep, 4x, bring down the plus 5, equals 9. No, because positive 8 minus 4. Yeah. Okay. Then from here, it's just a normal two-step equation to solve. So what do I do next?
-5.
Yep, minus 5. So 4x equals 4. And then what?
Divide 4.
Yeah, divide by 4. Stop with the side conversations. So x equals what? 1. So phone should be away. Phones should be away. Notes should be out. Should be writing this down. There's blank paper over there. Okay, so that is when you have the like terms on the same side of the line. So here, let's make a note of that. So this is when like terms are on the same side of the equal sign. What we're doing in 1.6 now is we are doing it where the variables are on both sides of the equal sign, not like together on the same side. And then when it's like that, they're still referred to as like terms, but this we wouldn't call it combining like terms, okay? So this is when you have variables on both sides. Mm-hmm. So that one that we're going to do is this. Okay, so if I were to get this problem and I just look at the left side of the line, do I have any like terms to combine? 12 and 6n, are those like terms? No. Just the right side, do I have like terms to combine? No. So do we see the difference between these two? Whereas this one, on the left, we had the like terms together on the same side to combine, right? So that's when you are going to actually do like the solving steps. So if you kind of look at this or kind of just analyze what we're doing here, this combine like term step is the only time where we are not doing the opposite, right? Like we're just combining it exactly as it's written. Otherwise, then if it's plus 5, we did minus 5. If it's multiply, we did divide. So we had to like do the inverse whenever we're trying to do everything else. The reason why is because for everything else, we are trying to move things over to the other side of the line. So anytime you're trying to move things from one side of the line to the other, that's when you are having to do the opposite or the inverse, okay? So now, when we're doing this, it's really up to you how you want to like structure the method that you're going to use. I personally always, no matter what, move the variable that's on the right side over to the left side. just because it's more important to me to end with the variable on the left, like x equals or n equals, like this, instead of the variable ending up on the right, especially because when we do inequalities next, that's going to get confusing. Some people will do it, they'll move whichever one ends with like a positive answer. If you don't want to divide by a negative, it's just up to you. But I'm always going to move this over to that side just to keep it the same every single time, okay? So what you're going to do is you're going to go in and find the variable that's on the right side, so the 8n, and you are going to have to do the inverse to move it over to the left side. So you're not going to divide because we're not trying to separate the 8 from the n. That's staying as one whole chunk. We're separating the 8n from the 2, okay? So what's the opposite of positive 8n? Yep, so we're just going to subtract the 8n, the whole piece. And then when you do it on the other side of the equal sign, you're going to want to do it to whatever one the like term is. So would the 8n go with 12 or 6n? 6n. Yep, so we minus 8n. And then that's going to cancel out right there. So bring down your 12. And then what's 6n minus 8n? Yep, negative 2n. And bring down the 2. And then from here, it's the same as they all end up, just a two-step equation. So the only new thing is moving the variable from the right to the left. Okay? So now what am I going to do to finish solving this? Guys, can we get the phones away, please, and focus, and move our desk back over? Thank you. Huh? No. I'm talking to Olivia. Can you just move your desk back over, please? What do I do next? Yeah. So you subtract 12 because you're trying to make 0. Does that make sense? Because if I add 12, then that's going to make 24. It's not going to cancel. Then you have negative 2n equals, what's 2 minus 12? You have negative 10. Okay, and then what? Yeah, divided by negative 2. So what's n going to equal? 5. Yeah. I am noticing on quizzes, guys, that some of us are very clearly not letting the calculator help us. Let the calculator help you, because some of us are getting things wrong because we're trying to do it in our heads. All right, so this one, so the like terms are on the same side. This is when the this is when you have the variables and the constants on both sides instead of the like terms being on the same side. Okay? Yeah. Okay. Okay. All right, so let's do a couple more examples. Let's do okay. Write this down. Guys, leave it alone. Write this one down. And draw your line. So look on the left side. Do I have any like terms to combine? What about the right side? No. Okay. That's not to say that that won't ever be a yes. So today we're just focusing on the ones, like the only new thing I wanted you to do today is focusing on moving the variable over to the left side. Tomorrow, or not tomorrow, Tuesday, we're going to add in like if you have to distribute on either side or combine like terms on either side like we've been doing. And then after you're done with distributing, combining like terms, you still have x's on both sides. Okay? All right, so what? Which of these x's is going to move? Yeah, the negative 7x. So how am I going to move that? Yep, add 7x. And then what am I going to add it to, the 1 or the 8x? The x, yep. Cancel that out. So bring down the 1. And what's negative 8x plus 7x? Yep, negative 1x. And then bring down your negative 4. Good so far? Mhm. Well, is it positive or negative? So then how do I get to 0? Yep, so minus 1. So you get negative 1x equals negative 5. And then what? Yeah, divided by negative 1. So what does x equal? Mhm. Good? Make sense? Okay, do you guys want to try one? Mm-hmm. Are you confused about the?
No, like, okay, 8x and 7.
Mm-hmm. So it doesn't. You could, if you wanted to add 8x to the right side, you could. It doesn't matter. I personally just have always decided I'm going to move to the left. So that way my answer always ends with the x first, like on the left side. Yeah, but it's up to you. Okay. Okay. This one you guys try. Okay. We go check. Mm-hmm. Yeah, just yeah. What do you do? So always take the one that's on the right and move it over.
Okay.
The A, yeah, first. Yep. So the negative 6a is where you're gonna move first. Guys, good son. Are we done or not yet? Not yet. Okay, keep going. Mm-hmm. Yeah. No, because it's plus 6a, right? That just goes away. So you have to add the whole 6a plus 6a. Yeah. But on that side, yeah. And then you add the 6a over to the negative 2a. Okay, ready to go over it? Yeah? Okay, so what am I going to do first? What's going to move? Yeah. Add 6 what? Add 6a, yeah. Add 6a. Guys, focus, please. Yep, so that's going to be positive 4a. And bring everything else down. Okay? Yep, then minus 7. So 4a equals 8. Yep, divided by 4. So what does a equal? Yep. Okay, we good on that one? Okay. All right. Okay, so we only have one more thing we have to go over. I mean, technically you can do either, but that's my rule that I have for myself, so it's just easier to have the same thing every time, so you know what to do. Mm-hmm. Yes, if you added the 2a over instead, then you would end up basically with negative 4a on this side and negative 8 on this side, so you'd still get positive 2. Yeah. Those are ones. So one, put 1 in front of both those. All right, so now we need to quickly talk about these special cases, which we already did, like, wrote down stuff about this and already talked about it, but now this is where it like really comes up. So we're gonna do an example of both of those. Okay, write that one down. Okay. So for this one, so what would I have to move? Yep, the 4b. So how am I going to move this? Yep, minus 4b. It's going to be something. So what on this side was 4b minus 4b? What's 4 minus 4? 0. So do I put b? No. Let it cancel out. So it's gone. Okay? If it goes to 0, just let it go away. So you're left with no variables. They both canceled out. You have negative 3 equals negative 1. So what you need to do now is decide if that statement is true or false. So does negative 3 equal negative 1? No. So this is a false statement. So that's going to be no solution. Okay, I'm going to do one more. Okay, write that one down. Mm-hmm. Yeah, but the truth is not that way you say your answer. Mm-hmm. Yeah, yep, yeah. Okay, so this one, what would I move first? The 7n, so how would I get rid of this 7n? Yep, minus 7n. Hey.
Hi, sorry, can I pull out anyone that's wearing blue real quick for a picture?
Sure.
Thank you.
Anyone wearing blue, go out there. No.
This is blue.
Guys. Yeah. Whatever, we just finished this. Okay. So 7n minus 7n, what's 7 minus 7? 0. So you end up with negative 8 equals negative 8. So is that a true statement or a false statement? That's a true statement. So that's you're going to have infinitely many solutions. Guys. Or you can abbreviate that by saying IMS. Or you can say all real numbers. You'll see it all different ways.